Cancellation tokens in .NET allows the user to express lost interest in the result of an operation. This can be at the function level, class level, API endpoint, etc. But does that mean all requests are the same and can be cancelled the same way? Short answer, no. So let's learn some good practices when using cancellation tokens in your application code. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. This video is part of my C# series, and thanks to AWS for sponsoring this video. In a previous video, we learned how cancellation tokens are a great way to implement cooperative cancellation of long-running tasks or asynchronous processes when building .NET applications. It allowed us to cancel out of long-running process and also HTTP requests that our application code makes to external services. This helps to reduce the unnecessary time that the server would have otherwise spent processing those requests, even if the user was no longer interested in the result. If you haven't watched that yet and don't have a good understanding of why and how using cancellation tokens is important, now is a great time to do that. It will be linked here and in the descriptions below. This brings us to the question, should all operations be cancelable? Let's explore that by looking at an example. So let's switch back to Rider, where I have an existing solution open, which is the same solution that I used in my previous video on cancellation tokens. Here we have the API endpoint, so let's navigate to the program.cs. In here we have two functions. Let's look at the post function in here. So this is right now uploading a large file to Amazon S3. Amazon S3 is an object storage service that provides scalable and secure storage service. To connect to Amazon S3, I'm using the Amazon S3 client provided by the SDK, and I use the put object request. Now in this case, it's uploading a large object, and we saw how implementing cancellation token supports cancelling out of this operation if the user is no longer interested in uploading this file. So let's say once we have done with the file upload, we need to do some additional processing inside here. So let's simulate that by using a functional call, perform additional tasks. Now in this case, this takes a cancellation token. So let me simply pass on the cancellation token that I receive from the API endpoint. Now we learned that this is automatically injected in using the ASP.NET framework and is wired to the request aborted cancellation token. So anytime the user aborts the request, this cancellation token will be invoked and will be cancelled. So let's navigate into that function. This is simply doing a task.delay of 1 second, and it's publishing an event into Amazon SNS. Now, SNS is a simple notification service and is useful for publishing and subscribing to messages. So in this case, I've already set up a topic to publish to, and there is a subscriber in there. Now, it doesn't actually matter what service you're using. What matters is that we are performing some additional work right after our uploading of file. Now, this could be sending a message to a queue or sending an email, etc. So let's put a breakpoint in the await call and run this application and see this in action. It launches the Swagger UI, so let's open this in a new tab because this particular instance is wired to the debugger. And if I navigate away, it will shut down the application as well. Let's go to the large upload file, click try it out, and upload a large file. Let's choose the large file and let's click execute. If the user was to navigate away right now, it would cancel out of uploading the file. However, in this case, let's wait a slightly longer time. So let's wait till it hits the await additional tasks and has done with the file upload. This application has already uploaded the file and is waiting to perform additional tasks. Now, if the user continues and waits on that page, it is going to perform this additional task and publish this message into the queue. However, what if the user cancels out of this operation at this point? So let's come back to our Swagger UI and navigate away from here, which should invoke the cancel on the token. So let's continue this execution. So let's also put a breakpoint in the operation cancelled exception and continue running this. Now in this case, it is hitting the task.delay, which is also passing the cancellation token. So let's continue executing. And this has now thrown the exception, operation cancelled exception. So now we are in a state where we have already uploaded the file successfully and we are broken out of this additional tasks because the cancel was called on the cancellation token. Now we have left our system in an inconsistent state. So if we were to navigate to Amazon console into the S3 bucket, in this case, the user service large messages. So inside here, we can see that there is a file that's uploaded right now. So you can see there's one file which is uploaded on March 26th at 4:42. However, once uploading, it did not perform these additional tasks. So this brings us to our first recommended practice, which is avoid canceling operations after you have incurred side effects. In this case, our application code has already performed a side effect and has changed the state of the application. It has successfully uploaded the file, and in this case, any function that has to happen after that should not be cancelable. Or if at all it has to be cancelable, you should be doing additional compensation work on your side. In this case, it would mean to delete that uploaded file and send back a response that the user operation is cancelled. Now, as for the caller, they must understand that not all work is cancelable. This means even if the user navigates away or explicitly calls cancel on the operation, it should expect that the work might not be cancelled. So it should be ready to do any of the cleanup activities from its end as well. Now, this highly comes down to your application scenarios and how you implement it. So in this case, you could show a notification to the user saying that the file is already uploaded, and if you want to delete, do these additional steps. You could also do the cleanup activity by yourself by handling the cancellation and going and manually deleting these files from S3. So you could queue another message into SQS or SNS to delete this additional work. Now, how you go about this is completely up to your application. So in this case, we could choose to remove the cancellation token from this function so that this function does not use the cancellation token anymore. So what we could do is remove this and take it off from the task.delay, etc. But that brings us to the next recommended practice, which is make the token optional on public API and required elsewhere. Any of your public API endpoints, you can make the cancellation token optional, so it's up to the caller to pass in a token or not. Once you have passed their public API endpoint, make sure that it is required elsewhere so that it's an intentional choice every time somebody writes the code to pass the token. So in this case, rather than removing the performing additional tasks, let's keep the cancellation token in here and make it the caller's responsibility of this function code to pass that in. Now, in this case, our public API is the cancellation token API endpoint, where we have set it up as cancellation token, and we could mark this as optional by passing in a default value in here. However, the ASP.NET framework will automatically wire this up every time a request is made to the request cancellation token. So in this case, it is not applicable as much to make this default. You would have seen many of the SDK calls, like in this case, when we say publish async, that the cancellation token here is optional and it by default uses the default of cancellation token. So this is basically them following the recommended practice of making the cancellation token optional in their public API endpoint. This is quite the pattern that you can see with many of the .NET SDKs that you use day to day. So let's leave the perform additional tasks and pass the cancellation token explicitly, which brings us to the third point, that is to use CancellationToken.None after point of no cancellation. So once you've incurred a side effect in your application, you can start passing around the CancellationToken.None after that point. So you don't have to propagate the actual cancellation token that you received in your public API endpoint, but pass on the CancellationToken.None. This makes it an explicit choice on whoever is writing the code. So let's come back to our application and let's fix this by passing in CancellationToken.None. Now this inside here refers to the default implementation and it ignores the cancellation token that is passed from the ASP.NET Core framework in our scenario. So if we were to run this application again, so let's navigate into the post large file, let's select the large file and let's say execute. So now the file upload is complete. So let's switch back and navigate away from this UI to invoke the cancel and let's continue the execution. Now in this case, the cancellation token that's passed around is CancellationToken.None and not the original cancellation token that was passed into us through the API. So let's continue this execution. So let's put a breakpoint in the results.no content. Now in this case, it has successfully performed the additional task and it has also sent the message to the SNS client. However, if you look at the cancellation token in here, you can see that the cancellation is already requested in this, but we still continued the process. This is because we passed on the CancellationToken.None after we have incurred side effects inside our application. This ensures that the application runs to a stable state and does not throw an operation cancelled exception. Now, if the caller explicitly called the cancel, it will have to listen to this and see what the response from this request is, and perform additional cleanup tasks if it's required. If you have been enjoying the video so far, please don't forget to hit that like button. And while you're down there, also hit that subscribe button, which helps me to grow this YouTube channel. Now, when using CancellationToken.None, the cancellation token cannot be cancelled. So in these cases, if your functions can be made more performant by not having to check the cancellation token frequently, you can use the CancellationToken.CanBeCancelled property. So this lets you know if the operation can actually be cancelled or not. Now, anytime you're passing the CancellationToken.None, the can be cancelled will be false, which means that this token cannot be cancelled. Now, in these scenarios, you could choose to have a different implementation for your function, which is more efficient. Now, one of the best examples for this is the Task.Delay. So let's switch back to Rider. Let's navigate into the Task.Delay method. Rider automatically disassembles this code and shows the internal implementation. So let's navigate further into this method, which calls the delay function. And in here, you can see that this is checking CancellationToken.CanBeCancelled. So if it can be cancelled, it uses the delay promise with cancellation class. Otherwise, it simply uses the delay promise. So it has two different implementations based on whether the cancellation token can be cancelled or not. So if your function code, it can also do something similar and work more efficient if it is a cancellation token that cannot be cancelled, you can use a similar approach to split the functionality and the implementation of your code. This brings us to our last point, which is ignore the cancellation token if the work is very quick. Now, if you have an API endpoint or your function does something really quick, and in which case this cancellation token doesn't make any sense, you can completely ignore this. Now, again, this is an intentional choice that you need to make when you're writing your function code or your API endpoint. So the next time you pass around that cancellation token, think again. Is this work cancelable or not? Blindly passing around the cancellation token has its consequences and can leave your application in an invalid state. So make an intentional choice on passing the same cancellation token or passing in a CancellationToken.None. Have a great rest of your day and see you in the next video.